All right, so I started this and then my husband called me, so I'm going to try to start again. All right, so let me show you what we're going to do. I don't always do homework, but I thought it would be helpful because I think this homework is really nice and it's really what I expect you to be able to do. All right, so the first thing I noticed is that I have 4 sine of something. Now the first thing I did, I'm going to show you my whole page. First thing I did in red is I went through and I filled in all the magic numbers for the sines. You see? There it is. There it is. All my sine magic numbers. All right? So I've got sine magic numbers filled in. The next thing I'm going to do is say, all right, so what has to happen here? I've got pi over 4. I've got a 4 times. So to fill these in, this is really easy to do. 4 times the magic number, so 4 star minus 1. Okay, so whatever's right here, and I had all of these in my homework, or in my notes, wrapped in parentheses. Just so you know, that's where the parentheses is. So that's 4 times the magic number minus 1. So I went in and I filled those in, because those are the magic numbers, got those filled in. The next thing I started with a video was that b is equal to 1/4. See how it's theta over 4 or x over 4. If you don't like theta, you can use x. So x over 4 is the same thing, so b is 1/4. So p, the period, is equal to 2 pi divided by b. That means I have 2 pi divided by 1/4. Well, just taking on the front side of this, 2 divided by 1/4 means 2 times 4 over 1, which is 8 pi. Now that pi comes right back into it. I just leave it off until the very end. So 8 pi is where I'm going to end up with right here. And you're like, wow, that's kind of weird. 8 pi is huge. It's okay. If p is equal to 8 pi, that's the period. The increments is 8 pi divided by 4 because it's the period over 4. That gives me each increment's 2 pi. Watch how simple this is. So if I start with 2 and my increment is 2 pi, then that means all I have to do is add 2 pi to 0, and 2 pi plus 2 pi is 4 pi, and 4 pi plus 2 pi is 6 pi. You got it? Okay, so now all I have to do, look how nice this is. Now 8 pi, I've got it highlighted, and I already have my green line midline in there so that I can see where the middle of my graph is going to end up. So I go to 0 and I start with -1. Boom, done. Then I go to 2 pi, which is right here, and I go to 3. It's right there. Then I go to 4 pi, which is here, and I'm at -1 again. At 6 pi, I'm -5. Boom. At 8 pi, I'm back to 0. And notice 8 pi is where I highlighted because that's where I had to be finished off. Okay? So I've got it right there. So now all I have to do is connect my dots. Now this one's kind of tall. It may not look scooped out or flattened out as much as usual, but it's going to keep going. And this one would keep going. So I put my arrows on either end. I can't repeat one. I can go over 2 pi and know that it repeats to here. Go over to 2 pi. From there, it goes back. I could have gone the full distance here and done something like that if I'd wanted to. Okay? Let's look at the next one. From the get-go, I've put in my magic numbers. I can tell this b equals 1, so my period is equal to 2 pi over 1, so that's just 2 pi. And there's no b in here, there's no c in here, so it doesn't get moved. It's going to end on 2 pi, and it's going to start at 0. All right, so these are my nice numbers. If you remember, if period is 2 pi, your increment is equal to your period divided by 4, which is pi over 2. So what goes in here is pi over 2, and going up by pi over 2 again is pi, and then 3 pi over 2, and those are the pretty numbers. All right, those are the really nice ones. Now the only thing happening to this And again, if you want parentheses, it's right there. The only thing going on with this is we're adding 1 to it. So this would be the magic number plus 1. So I'm going to add 1 to every one of these. 1, 2, 1, 0, 1. So I'm going to go right here, my midline. I'll put my midline in at 1. Okay? And then I'm going to go ahead and make out 0, up 1. I'm going to start with 1. Pi over 2 is 2. Pi is 0. 3 pi over 2 is 0. 2 pi is 1. And I'm right here. Now, I can put an arrow on the end of this to know it keeps going. If I wanted to know what was going to happen, I would skip 2, and this is where it goes up 1, skip 2, back down 1. Technically, it would curve and keep going like that. Okay? All right. Let's look at the next one. Another really nice one. Okay? This one's nice. Moving things out of the way here. I'm a little bit of a mess. All right. So, again, I'm at pi over 3. So, I do know some things are going to happen over here because it's definitely going to change up my x. It's not going to be pretty as it was. But I do want to show you that the only thing happening outside of these parentheses is this minus 1. So this is going to be magic number minus 1. So I'm going to take 1 away. Puts me at negative 1, 0, negative 1, negative 2, negative 1. I've already got all of those numbers done. That also means that down here, because this is a negative 1, this is going to be my midline. It's going to be centered there. Now, what I have to do is my b is equal to, you see this theta over 3, it's the same as x over 3, so it's 1/3. All right, so that means my period is equal to 2 pi divided by b, which is 1/3. Now I'm going to take this 1/3 and I'm going to go, well, that means 2 times 3 over 1, which is 6 pi. It takes 6 pi to complete this. Now the good news is there's not a shift left or right, so I'm going to start with 0 and I'm going to end on 6 pi. Now if my period is 6 pi, then my increment is 6 pi over 4, which is 3 pi over 2. Not the nicest one I've ever seen, but not impossible to do. So this is 3 pi over 2. Now watch how I'm going to do this. I'm going to go 3 over 2 is my increment. I'm going to add 3 over 2, which is going to give me 6 over 2. And 6 over 2 breaks down to 3. So this is 3 pi. And then I'm going to add 3 over 2, which is 9 over 2 pi. 9 pi over 2. And then I'm going to add 3 over 2, which is 12 over 2 pi, which is 6 pi. Does that make sense? Oh, shoot. All of that was on the paper down below. Okay, here's my list. I started with 3 over 2 because I knew my first jump was going to be 3 pi over 2. So I started with 3 pi over 2, and I added 3 pi over 2 for my increment, got 6 over 2, and 6 over 2 is just 3. This is an equivalent of 3, okay? Then I added 3 over 2 and got 9 pi over 2, which doesn't break down. And then I added 3 over 2 and got 12 over 2, which is another 6 pi. Okay? Make sense? All right, now with that said, now think about this. The 9 over 2 is 4.5 pi. So it lets you know it's in between 4 and 5 pi. The 3 over 2 where I went to, that's 1.5 pi. So we've got our increments that are a little bit different, okay? So we're going to start at 0, 0. I don't want to go too far down on this. We're going to start at 0, 0, 0, negative 1, goes right there. And then 3 pi over 2 is going to hit at this 1.5 pi. It's in between 1 and 2 pi. So 3 pi over 2, the value is 0. Oh, it's going to hit right on 0. And then, so look, it went 1.5 boxes. So there's 1.5 box. I'm back at 3 pi. Holy cow, do you see it happened? All right. And then 1.5 pi is going to be right here, and it's going to go to negative 2. And notice that's the same thing as 4.5 pi. So it's in between 4 and 5, right there. And then the last one is 6 pi, and it's going to end up at negative 1. So there it is. Okay, there's my sine curve. So I'm going to connect it. Oops, that wasn't not as pretty as I wanted it to be. And I'm just going to put arrows on it and stop it. I'm glad to stop on that one. When they're weird like that, I really don't want to repeat another one unless I have to. All right, looking at the last one. Now, this one's a little strange because it has a 5 pi over 6, which means we're going to start in some weird areas right here. So what I'm going to do is go ahead and figure out this piece. This piece isn't bad. Look what's being added onto this. This is being multiplied by 2 and add 2. So I have 2 times the magic number plus 2. Well, 2 times 0 is 0, plus 2 is 2. So I've just filled out all of my zeros. Look how easy that was. Then I've got to have a 1 in there. 2 times 1 is 2. 2 plus 2 is 4. I got a negative 1. 2 times negative 1 is negative 2, plus 2 is 0. I'm done with all my hard stuff. Well, with my easy stuff, with the y values. Okay, got my y. Now, one thing I want to do is notice that my last number back here is a 2, so that means this is my midline. And now I've got to do a little bit of math. I've got the b. Let's go up here. b is equal to 5/6. Okay, that's what my b is. So the period is 2 pi over b. Holy cow, let's cry. No, it's okay. You don't have to cry. It's easy. So we're going to take this and we're going to multiply it by flipping it. So it's going to be 2 times, and I said I was not going to do this to you, and that's what happened. Dag nabbit. All right. It's going to multiply. You keep, change, flip. Okay? And, oh my word, that is not the b. I feel like an idiot. Did I really do that? B is 1, thank the Lord. Oh my gosh, B is just 1. This is the C. C is 5/6 pi. This is so easy now. Oh my gosh, I didn't just do that. I was like, seriously? I can't believe that just happened. Okay, B is 1, so that means 2 pi is where it's going to stop. B is 1, so the period is 2 pi. Not as bad as I thought for. So that means if the period is 2 pi, our increments are 2 pi over 4, which is pi over 2. Now this is a little bit of a pain because it has to start at negative 5 pi over 6. So this is negative 5 pi over 6. Now, if I'm starting at negative 5/6 and I want to add pi over 2, I need to turn this pi over 2. This still is not nice, but it's nowhere as bad as it started. Okay, so if pi over 2, I want to turn this into something pi over 6, what would give me 1/2? 3 pi over 6. Does that make sense? Let it set in a minute. Let me get it up there high enough so you can see it. So we've got pi over 2, that's 1/2 pi, is the same thing as 3 pi over 6. Now, why do you think I would want it to add a 3 pi over 6 to each one? Because I'm starting with 5 pi over 6. Now, I'm going to leave off the pi for each piece of it, and I'm going to add 3 over 6, which will give me negative 2 over 6. And then I'm going to add 3 over 6, which will give me 1 over 6. And then I'm going to add 3 over 6, which will give me 4 over 6. And then I'm going to add 3 over 6, which will give me 7 over 6. Now I'm going to do this until I get 2 pi ahead. Now I only need 5 of these. 1, 2, 3, 4 more of them. So this is the first one. This is 1. This is 2. This is 3. This is 4. Holy cow, we got it. This is 5. So I've got everything that I need, but I want you to see that it comes out a little bit strange because 2 6 reduced to negative 1/3. So this would be negative pi over 3. 1/6 pi is pi over 6, and 4/6 pi is 2 pi over 3. And the last one's going to be 7 pi over 6. Whoo, doggies. Yeah, that was a load of fun. Yeah, let's do 5 more of those. Just kidding. All right, so on this one, we're going to have negative pi because our increments are adding by pi over 2, which is the same as 3 pi over 6. Okay, so I'm at negative pi over 3, and then I'm going to be at pi over 6. They didn't give me enough room. I just looked at this. This was not nice of them. They gave me this graph, and I mean they because I used software for this. There's not enough room on this graph to get it. This is not nice. I don't like them. All right. And then the next one is 2 pi over 3. And the last one is 7 pi over 6. Boy, what is it with the last one of numbers that we do? They go south and they get very difficult. Okay, if this is pi and this is pi over 2, here's the craziness. This is like 45 degrees, so my pi over 6 is going to be right here. So pi over 6 is here. Pi over 3 is really close to this side. And I don't need pi over 3. I need a negative pi over 3. So let's see. Negative pi over 3. And I just kind of like skipped some of this. Holy Toledo. This isn't nice. This is negative pi over 6. And then my next line out here, why did they not give me enough? Because that one is pi over, that's not negative pi over 6. Negative pi over 6 is actually over here. This one's negative pi over 6. Because that's pi over 2 there. This is not nice. I can't get it all in here. It didn't give me enough room. If this were to keep going backward, it would be over here because it's all finished up by the time it gets to 7 pi over 6, which happens to be right here. Oh, why do you do this to me, people? Okay, let's graph the ones that I can. This is not nice. I have to start at the pi over 6, and it's going up to 2. Pi over 6 is all the way up to 2. Now it's cyclic, so I can figure out part of it that I can see. No, before you ask, you will not have one this hard on the test because I will make the graph fit. This wasn't nice. I'm not happy with them. I didn't ask for difficult ones, and it gave me this one. Dadgummit. All right, so let me see. 2 pi over 3 is going to end up, I need my chart. Let's get some help. 2 pi over 3 is right here. It's really close to 3 pi over 4. Which one do I have? It's right above pi over 2 and just before pi. So it's right before 5 pi over 2. So this is the halfway mark. That's pi over 2. This one should be after pi over 2. Nope, it should be right here before pi. I think what they were thinking is that it was going to go here, and it's 15 degrees off. So it's not exactly where they thought for. This one's hitting at 0. And then pi doesn't even come in. It's 7 pi over 6, which goes right past pi by 30 degrees. This does not make sense to me. And then this is at 2. It's back up on 2 again? Okay, this tells me this one should be closer to this mark. I'm not happy about this. I don't know if they didn't keep these marks true. They should have. There's pi over 2. This is pi over 3, pi over 6, 2/3 pi. 2/3 of the way to pi is just over half, but that's 3/4, so it should be right here. And pi over 6 should have been there. It's only 15 degrees off. Oh, you know what? This is pi over 4. I messed up because this is pi over 4, so this number should have been here. Okay. This should have been pi over 6 because this number is pi over 4. That's what's messing me up. And 2 pi over 3, do I have a negative pi over 3? It's going to end up like kind of here. So this is going to come up and back down. But I never got to 4. Oh, cute. Pi over 3 was at 4, not at 0. This is pi over 3, somewhere up here. And I'm not even at the end yet. 7 pi over 6. 7 pi over 6 is just past pi, so that's somewhere up here, and it's up at 2. Well, how is that at 2 when 3 pi over 2, it's just past 3 pi over 2? 7 pi over 6 is here. I know what I'm doing. I'm still thinking this number right here is over 4, is the over 4 number. This is 5 pi over 4. I had that set in my head wrong. So it all happens before and after 5 pi over 4. So it's here and here. And this one ends up right here at 2. This is like terrible situation because I can't see my whole graph. I don't like this. Okay, so if I did another one, plus 3 over 6 is 10 over 6, which is the same as 5/3. Yeah, all of them ends up at thirds. Guys, I'm not going to give you one. These, I am not happy with them because I'm using a program to make these things. It's going to end up doing something along these lines, but I don't even like this. It's just not, no. This one, you will not have one that ugly. Sorry. The end.